Good evening, my dear students. This is Venkatesh. I am your physics faculty. Today we are going to discuss about the topic name is Newton's laws of motion. The Newton's laws of motion is central importance in classical physics. The great scientist Newton derived three laws. By using these Newton's laws of motion, we derived many principles and we conclude many results also. First, we are going to discuss about the Newton's first law or the first law of motion. First law of Newton's first law says if sum of all the forces acting on the particle is equal to 0, the particle is unaccelerated or the particle is at rest or moving with a constant velocity. So, if sum of all the forces acting on the particle is F bar and acceleration is A bar, we can conclude the statement acceleration equal to 0 if and only if net force acting on the particle is equal to 0 and vice versa. Means acceleration of the particle is equal to 0, we can be sure that sum of all the forces acting on the particle is equal to 0, or sum of all the forces acting on the particle is equal to 0, we can be sure that acceleration of the particle is equal to 0. However, we measure the particle state or its state of rest or motion and acceleration accurately by using the reference frames, or we refer the reference frames. Okay, here if we measure the acceleration of the particle is different when measure the in different frames, means acceleration is different when we measure the in different frames. So here Newton first law also different in different frames, so we can take one example. So here the one hanger and this is the cable and this is the cabin, means this is an elevator, and this is the ground, and in elevator all the bodies are fixed, means we are taking the lamp by using the string fixed with the cabin. This is the lamp, and a person who is in the cabin at point A, means at point A means the with respect to the cabin, and another person who is observe the cabin outside the cabin, and means with respect to earth, So here if we cut the cable, the cabin is falls down on the earth. Here what forces are acting on the cabin? The gravitational force acting on the cabin. That's why this is falls down on the earth. So here we observe the with respect to the cabin and with respect to the earth. First we are observe with respect to the cabin. So in the cabin, on the lamp, how many forces are working? Two forces are working. One is gravitational force, another one is electromagnetic force, means tension T applied by the wire or applied by the rope. Okay, first case means we are observing the with respect to the cabin. First case the gravitational force is applying downward. So the gravitational force is equal to mg, which is downward direction, and tension T is upward direction. So according to Newton's first law, the sum of the forces acting on the particle is equal to 0. So weight is downward and tension is upward. So weight is downward minus tension T equal to 0. So weight equal to tension. So second case is what? We observe the cabin with respect to the ground, means a person who is observe the cabin with respect to the ground, and okay, right, with respect to the person B, the cabin is falling on the earth. So with respect to the person B, he is seeing the lamp also falling down on the earth. So with respect to B, here what will happen? If we apply first law, the sum of the forces, what will happen? Weight minus tension not equal to 0, because of the cabin is falling down on the earth. If with respect to B, weight minus tension equal to 0 means what? There is no moving with the lamp, but here with respect to B, the lamp also moving, or the lamp also accelerated. So weight does not equal to tension. So here person A can be measured. So he got the weight equal to tension. Person B measured weight not equal to tension. Here, if we observe the both cases simultaneously, Newton's first law is not valid. So here Newton's first law valid only we measured one by one. So here a person, here with respect to person A, lamp is not moving, means lamp is at inertia, means lamp is not moving. With respect to B, cabin is moving, means here inertia is not working, means non-inertial is moving. So here the two concepts are coming, means one is inertial frame, another one is non-inertial frame. So what is the inertial frame? The frame of reference in which the Newton's first law is valid, called as inertial frame, and the frame of reference in which Newton's first law is not valid is called as non-inertial frame. So here, by observing the ground, generally we are taking the inertial frames, and why we are taking another example. What we conclude by this example, another example, why we are taking with respect to the earth as inertial frame. So here So a book is placed on the table. Here the book is at rest. The book is not moving. Here what are the forces acting on the book? First one is gravitational force. First one is gravitational force. So gravitational force pulling downwards, or gravitational force is downwards. W equal to mg is downwards. And another one is contact force also working, which is upward. Which is upward. If we measure, or here we are applying Newton's first law, the sum of the forces equal to 0, means weight minus contact force equal to 0. But if we measure accurately, weight not equal to contact force. Weight not equal to contact force. What will happen? Here we are observing with respect to ground. Ground means earth is not inertial frame, means earth is moving. Moving means which is not inertial frames, but approximately weight and contact force are very close to the 0, means the sum of the weight and contact force is close to the 0. That's why we are taking earth as a inertial frames. So here we are taking one example. By using Newton's first law, we are solve the one problem. Yeah, first problem is, there is a hanger and a body of mass m which is fixed with the string m. A body of mass m which is fixed with the string. Okay, the force exerted by the string on the mass, means what is the force exerted by the string on the mass? Here question is what is the force exerted by the string on the body. So here, according to Newton's first law, the sum of the forces acting on the body equal to 0. What are the forces acting on the body? One is gravitational force, W equal to mg, which is downward. Another one is tension T, which is applied by the string. So we are going to find out the tension T. According to Newton's first law, the sum of the forces acting on the body equal to 0. So here weight is downward and tension is upward. Direction is opposite. That's why weight minus tension equal to 0. So weight equal to tension. What is the weight? mg. So here tension is what? Here tension is tension T is equal to mg, right? This is about Newton's first law. Okay, next we are going to discuss about the Newton's second law. Second law of motion. Second law of motion. The Newton's second law explains what? The acceleration of the particle we measured with respect to the inertial frames is given by the sum of all the forces acting on the particle is divided by the mass m or body mass m. So mathematically we can write acceleration of the particle is equal to force, means sum of all the force acting on the particle is divided by m, or some force acting on the body of mass m, which is definitely an acceleration. That acceleration is what? Acceleration is equal to force by m. Okay. So this is the Newton's second law, or force equal to ma. Force equal to mass into acceleration. So here, by using Newton's first and second law, we are going to discuss a problem. So we are going to the problem 1. By using Newton's first and second law, we are going to solve a problem. First, we are taking 4 steps. First step is identify the system, or decide the system. Decide the system. Second one is identify the forces acting on the body. Identify the forces acting on the body. And third one is draw the free body diagram. Or making the free body diagram. Making free body diagram. And fourth one is choose axis and write equations. Choose axis and write equations. By following these 4 steps, we are going to discuss a problem by using Newton's first and second law. The problem is a body of mass m which is pulled on horizontal table by a string. The string making an angle theta with respect to the ground. And the acceleration of the body is equal to a bar. So here find out the tension T applied by the body, or the tension T applied on the body, and another one is the find out the force applied by the table on the body. So we are going to draw the figure clearly. By using figure, you have clear idea. So here the table there, and a body of mass m, which is connecting with the string. A man is pulling the string, and just wait. A man is taking the angle theta. Means here a body is moving on the table, and a man is pull the body. Okay, here find out the tension applied on the body. Tension applied on the body. And second one is find out the force applied by the table on the body. Find out the force. Find out the force by the table on the body. Before I told 4 steps. First, select the body, and next identify the all forces acting on the body. Third one is making free body diagram. Fourth one is choose axis and derive equations or write equations. First identify the system. Here we are taking body as a system. First, here body as a system. Here system we are find out. Next one is identify the forces acting on the body. What are the forces acting on the body? First one is gravitational force. Gravitational force which is downward, W equal to mg. Another one is contact force which is applied by the table on the body, which is upward. Contact force which is upward. And third one is tension T. T is applied by the string on the body. Okay, right. Next choose axis, and here we are going to draw free body diagram. Before going to choose axis, we are going to draw free body diagram. Okay, here the mass M which is on the table, which is moving like this, and weight or gravitation force W equal mg downwards, and contact force N is upward, and tension T is applied, and the rope or string making an angle theta with respect to the table. Okay, right. And next choose axis. The body moving on the table take as the x-axis. And the vertical directions are take as the y-axis. So now we are going to write the equations. First, along the x-axis what are the forces acting on the body, and next one is along the y-axis what are the forces acting on the body. So first, according to trigonometry, this one is T. This is the tension T applied on the body. So this is the T cos theta. This is the T sin theta. According to the trigonometry, this length is T cos theta, this length is T sin theta. Means tension vertical direction, tension T here T sin theta. So along the x-axis T cos theta, and along the y-axis T sin theta, and the gravitational force. So along the x-axis we are going to find out the forces. Along the x-axis any gravitation force is working? There is no gravitation force. Gravitation force working downwards. Along the x-axis there is no gravitation force. So first case is along x-axis. Gravitational force W is equal to 0, and any contact force is working on the body. This T sin theta is nothing but this is the tension T applied along the y-axis, and along the x-axis any contact force is working. Contact force is working along the y-axis. So contact force also equal to 0. But one force acting along the x-axis, that is the t cos theta, means this length. Along the x-axis, what will the force t cos theta? Force F is equal to t cos theta is working. Here by using Newton's second law, what is the force? Force F is equal to mass into acceleration equal to t cos theta. So here our first question is what? Find out the tension T applied by the string on the body. What is the tension? T is equal to MA by cos theta. MA by cos theta. This is about first question. Next we are going to the second question. Means along y-axis, what are the forces are acting? Along y-axis, what are the forces are acting? One is gravitational force, W equal to mg is acting, and along y-axis contact force also acting, N bar, and along y-axis tension T is applied. So T sin theta is applied. So Newton's first law, the sum of the forces acting on the body is equal to 0. Here we are applying the Newton's first law. The sum of the forces acting on the body is equal to 0. So weight is downward and contact force is upward, and tension also here working. So if you are taking directions, downward is negative, upward is positive. So here tension is upward and right one, means this is x-axis, this is y-axis. This is the tension T sin theta. So according to Newton's first law, the sum of the forces acting on the body is equal to 0. Here what is the along the y-axis? Contact force plus tension T sin theta, and gravitation force which is downward, that's why negative, minus mg is equal to 0. What is our second question? The contact force applied by the table on the body. So contact force F n bar is equal to, we are taking these two terms to the right, mg minus T sin theta. Already we have derived tension here. So tension T equal to MA cos theta. Submit to in this equation mg minus T. T means what? MA cos theta. And this is MA by cos theta. And here what is there? And into sin theta. So according to trigonometry, sin theta by cos theta gives tan theta. So mg minus MA tan theta we are getting. So along the x-axis we are getting tension, along the y-axis we are getting the contact force applied by the table on the body. So contact force n bar equal to mg minus MA tan theta. So this is the about first and second law. So we are going to the Newton's third law. So third law of motion. What is Newton's third law says? Every action there is equal and opposite reaction. Every action there is equal and opposite reaction. So Means if we are taking body A and we are taking body B. So this is the wall, this is the wall, this is the ball. This is the ball and this is the wall. Point A, we are taking a ball, throwing on the wall. So immediately ball returns to us. Means whatever force exerted by the ball on the wall also same force exerted by the ball, but in opposite direction. That's why whatever the ball we are taking and throwing on the wall, which is returned to us. Here third law says what? Every action there is equal and opposite reaction, but direction is different. So here point A is applying force on B and point B also applying force on A, equal in magnitude and opposite in direction. So force of A equal to force of B. So FA minus FB equal to 0. This is about Newton's third law. Okay, thank you. This is the about 3 laws of motion.